Inflammation. You might have heard this term, calor, dolor, rubor, tumor, and this is Latin. So this is Celsa. So this is actually ancient, or like from, yeah, we've known about inflammation for literally thousands of years. So this was known since around 47 Common Era AD. So calor, so same as in calorie or calorific, or if you've taken in Spanish or like things like caliente or yep, or things like even Italian bagna cauda, that refers to heat. And dolor, if you know taking the SAT vocabulary, dolorous or suffering and pain. And rubor, so this refers to redness. So again, this is where we get the term ruby from. What colors are rubies? Typically red. Same root word. And tumor, we're not talking about cancer in this specific context. So tumor in the original Latin word and root refers to swelling. So when you have inflammation, you have all these types of things. So like say you sprain your ankle, and this causes an inflammatory response. So what happens? Well, the area that's inflamed is going to get heat, pain, redness, and swelling. Or if you get an infection, you get all of these at the site of infection. So inflammation is your body's natural defense and also response to some sort of pathogenic infection or even some sort of injury. Now, mast cells are something that can cause that. So these release histamine. So histamine causes vasodilation. So what does vasodilation do to blood vessels? So again, vasal refers to vessel, and dilate, does that mean get bigger or smaller? Again, the difference, the dilation is the opposite of contraction. So instead of contracting, dilation means the vessel will get bigger. So histamine causes vasodilation. So what does that do to your blood vessels? It opens them up. It also increases the vessel permeability. So we're not just talking about increasing diameter. It's also going to increase the pores that are between these blood cells. Remember those endothelial cells? Histamine also causes little openings or makes it easier for cells, white blood cells, to squeeze between the endothelial cells lining your blood vessels. So what does that mean? So by increasing the permeability, and it increases the ability of immune cells to move from the inside of your blood vessels to the surrounding tissue that at the site of an infection. The thing about this pores and increased vessel permeability, not only can cells leak out, but fluids can leak out as well. So if you have these if your blood vessels are less intact and they have all these little holes in it, this causes fluid to leak. And so if you have all this fluid, the plasma and fluids leaking out from your blood vessels into the surrounding tissues, this is where you get the heat, redness, and swelling. So again, remember your blood does have heat because why? Water absorbs heat. So when you have fluids going out to the site of an infection or some sort of inflammation, that's going to carry the heat from the blood to the surrounding tissue. And heck, what else do you have? If, say, some red blood cells get there, you might have some redness as well. And you might also have swelling as well, because why redness? Due to increased blood flow, and swelling due to increased fluid in that area of the infection, or I should say inflammation. So this is another thing. So think about these white blood cells. They're not trapped within your blood cell or blood vessels. They're actually able to squeeze between endothelial cells lining your blood vessels and move to the surrounding tissue. So here we have inflamed tissue. So do you need to know about these specific receptors here? Not really, but do you need to know this term right here, diapedesis? This is how these cells, these white blood cells, are able to actually migrate from the inside of a blood vessel and go to the site of inflammation. So they're actually able to squeeze between these endothelial cells. Now let's talk about fever. So again, another part of inflammation deals with heat. So again, that calor. So fever, also known as pyrexia or febrile response. Do you often hear this term febrile in the hospital? Let's talk about fever. That's a fancy term for that, or medical term for that. So bacteria and immune cells can release these chemicals called pyrogens. So pyro, when you think of pyro, what do you think of? You think of fire, right? So pyro, we have heat and fire. So pyrogens, these are chemicals that are causing the body to produce more heat. So this is why pathogens can also cause fever. Why? Because they're releasing all these chemicals that induce inflammation and fever. Yeah, fire, fire. So, fever and thermoregulation. Yep. Ooh, anaphylactic shock. Do we have time for that? Well, maybe at the end of the lecture. All right, so fevers so think about fevers. So when you're cooking something on the stove, say you're making curry or soup, what happens if you just throw all the ingredients together and don't add any heat? Will it really cook? Will all the flavors really meld? Yeah, maybe like if you have a really slow cooker or if you leave it just at room temperature for weeks, it's not going to really do anything. But what happens when you add heat to a chemical reaction? It typically speeds it up. So this is another reason behind this inflammatory response and increasing the heat production during inflammation. It actually gives an additional chemical boost and helps to speed up reactions in your immune cells to help to produce and also make these, not only produce more ATP, but also helps them to produce more chemicals that help in defense. And think about fever. So again, you're just like you have your own typical normal body range, so do bacteria and other invading pathogenic cells. So fevers actually make it harder for these cells to thrive and replicate in your body. And these are, again, things like enzymes. Enzymes also have optimal ranges of temperature at which they operate. So if you have a fever, what does that do? Well, that's going to start to slow the efficiency of bacterial and viral enzymes. But the thing about why do fevers suck? Well, this also stresses your own cells. So just like degranulation can make it toxic for your own cells, fevers can also make it very uncomfortable for your body as well. So body temperature. So again, normal body temperature around 37 plus or minus 0.5 degrees Celsius, or if you're more familiar, 98.6 plus or minus 0.9. And the funny thing about this, I think the paper came out last year, but now they're saying like, hey, actually the normal body temperature might be a half a degree or a degree lower. And the thing is like, this is just a range. Some people actually have lower set normal body temperature and nothing else is wrong with them. This is also why it's important to have a primary care physician. Just in case your body temperature tends to be on the lower side, they know like, hey, you're not suffering from some sort of like hypothyroidism or underlying condition. So again, this is why it's important to have a doctor who knows you. Yeah, so if yours is always like kind of low, then and you don't feel unhealthy otherwise, I mean, you might have just a lower set point. So in general, a fever is when you exceed this range of normal body temperature. And again, if say you're like Haley and your body temperature tends to be around 97, say if hers actually goes up to 99, maybe that's a fever for her because her set point is actually lower than the typical or just like the population average. And hyperpyrexia. So why do they say you should call the emergency room if you think you have the flu and your fever gets out of control where you're all above 40 degrees Celsius or 100, I think the number they've been saying is 103. So this is not just a fever, this is way above normal. Hyperpyrexia. So again, fever is there to give a boost to your immune cells, but if it gets out of control, remember fevers also affect your own cells' happiness and able to function, as well as their enzymes. If your fever gets out of control, your own cells can start dying as well. And why did they add this asterisk? Well, these values may vary between hospitals, institute, or country, or even with new scientific discoveries, just like how they're discovering or they're seeing, hey, maybe this 37 is actually a little too high. So again, pyrogenesis and pyrogens, we're talking about fire, but antipyretics. So instead of causing fever, what are these going to do? Well, these are chemicals, and you might already know some of these antipyretics, or several, or you've actually seen them. Where might have you seen them? Well, you might also, if you know NSAIDs, these are non-steroidal anti-inflammatory drugs. So again, things like cortisol, that's anti-inflammatory, but it is a steroid. Again, important to know your structures, right? But these are non-steroids. So things like aspirin, ibuprofen, and Aleve. So these are all NSAIDs. And what do? they reduce your fever and lower your body temperature when you have a fever. So this is another thing. So again, if you have a fever over 103 degrees, you have hyperpyrexia, go to the hospital or call your doctor. But that's why, again, remember, fever is a natural response. I mean, it's not coincidental that it's part of inflammation. So another concept thing is new, the concept behind, okay, you have a fever, take a NSAID, take an antipyretic. But some studies are now saying like, hey, maybe it's better to, as long as you're not under hyperpyrexia, maybe it's better to actually let the fever run its course, even though it's very uncomfortable. Remember, if it's within a certain range, it is helping your immune system, and it is preventing pathogens from progressing in your body. Again, if you have hyperpyrexia, if you, in this situation, I don't think it's a good idea to let a fever ride. So again, if you're feeling comfortable, by all means, take a NSAID. Although there's another twist. Like I think just through doing statistics, they say ibuprofen might be contraindicated for coronavirus, the new coronavirus. So again, it's very complicated, but why is it complicated? We're just discovering new things every day about this virus. But again, if you have that above 103, 104 degrees Fahrenheit, by all means to get medical attention. So you have something called NK cells, and these are aka natural killer cells. So it sounds very scary, but they're actually they're kind of like all-arounder immune cells, and they're part of your innate immune system. Common misconception that they're part of your adaptive immune system, but NK cells, they're kind of like, how should I say, they're kind of like counter-terrorist agents. What do? They recognize abnormal cells and abnormal activity. So things like cells that are infected with viruses or cells that are potentially cancerous. So we recognize abnormal behavior in cells, and not in pathogenic cells, but in your own cells. So if any of your cells are infected by viruses or any of your cells start to become precancerous, these NK cells, they kind of know what to look out for when they see these virus-infected cells or tumor cells, and these cause apoptosis. Again, this is programmed cell death, so these NK cells can tell infected or precancerous cells to die. And again, it sounds very scary that this cell is telling another cell to die, but there's a reason why it's telling this infected cell or potentially cancerous cell to die. Because again, you want that virus to keep on replicating in your body, and you don't want the cancer to progress as well. And ooh, it's already 2:30, so I think I'll leave the other cells and dendritic cells for next week, Monday, when we cover the adaptive immune system.